Homework 6, Section 3.4, Logical Arguments, Video 6. The previous video ended with determining the implication for this argument written symbolically. And I challenged you to complete the truth table on your own before resuming this video. I've already got the truth table started, one column for P, one column for Q, and all of their possible truth value combinations. And I've already set up the columns that I'm going to need. How did I know I'm going to need 5 more? Because in the implication there are 1, 2, 3, 4, 5 connectives. Now I also did think in advance so that I would know how wide to make each column. When you're setting up the columns, you can mentally process the correct order in which to set up the connectives, and that will determine how wide you need to make your columns. For example, in the implication, at the top of the hierarchy of logical connectives are parentheses, and inside those are some more parentheses, and inside that is the implication, P pointing to Q. That finishes these parentheses, but it does not finish the outer parentheses. And inside the outer parentheses, there are still 2 more connectives, a conjunction and a negation. The negation takes precedence, so the next column is negation P, followed by the conjunction. So the next column is the conjunction of the things on either side of it. The conditional on the left, the negation on the right. I'm going to extend these lines upward because the titles of my columns are running into each other. Once we set up the column for the conjunction, that sets up everything inside the parentheses, so we move outside of it where we see a conditional, implication, and a negation. Negation takes precedence, so negation Q is next. And then lastly is the implication. Usually by the time you get to the last column, it's a really wide column. You can save a little space by just writing the giant parentheses on the left, but leave it empty, and then write the conclusion on the right. Or if you wanted to be even more brief about it, you could just draw the double-lined arrow and not put anything around it, as long as you know what's on both sides of it. All right, let's complete the truth table. Here's a story we've already heard in the first empty column. The rule is conditional. The rule is false if T points to F. And we are looking at the P pointing to the Q. If you need to draw the arrows to represent P pointing to Q, do it. And then look for anywhere where T points to F. That's only the second row. That's the only column, that's the only row in which this column will be false. Therefore, the rest of the column will be true. Again, pretty straightforward. The next column is just the negation of P. Negation means to change the values. So we're going to change the values on the P column. The P column is true, true, false, false. If we change them, false, false, true, true. Switching colors, let's go to the conjunction. The rule for conjunction is it's true only if all true. So that's the rule, and the columns we're applying it to are the column representing the left side, which is the conditional, so the third column, and the column on the right side, which is the negation, so the fourth column. Luckily, the 2 columns that I'm applying to this rule to are next to each other. So I'm going to apply this rule to these 2 columns. Don't look at these. I'm looking for anywhere where it's all true. No, no, here's one, here's one. Those are the only 2 rules, only 2 rows where this rule applies. True, only if all true. True, only if all true. That means the rest of this rows in this column are false. It's not too bad, especially since the columns I was applying the rule to were next to each other. Second to last column is just the negation of Q, pretty straightforward. we need to change the values of the Q column. Don't lose sight of where you are. Here's the Q column. We're going to change the values, write them over here. TFTF, FTFT. Let's switch to black. All right, time for the implication. Just the fancy conditional. So it's the same rule as over here. False if T points to F. So which columns am I looking at? On the left side of the conditional was the giant parentheses. The content of the giant parentheses was this conjunction. So we need the column that represented the conjunction. That's this column. So we're looking here. And on the right side of the conditional is just the negation of the Q. So we're looking here. Hooray, they're next to each other. And they're in the correct order. We need giant parentheses pointing to negation Q, giant parentheses pointing to negation Q. It would not be a crime if you only wrote a single lined arrow instead of a double lined arrow there. Now, we are looking for any row where T is pointing to F, and when we see it, we'll write false. No? No? Here's one. T is pointing to F. The rule says that's false. And no. Let's double check it. This is the only row where T is pointing to F, so this is the only F in the last column, which means the rest are true. And now that we've completed the truth table for the implication, we can answer the question, is the argument valid, by answering the question, was this statement a tautology? Remember, in order to be a tautology, the last column must be all truths. This one was close, but close isn't good enough. The implication is not a tautology. The implication is not a tautology. Thus, the argument is invalid. Not a tautology, therefore the argument is invalid. And what that means is, if these two premises are true, you cannot conclude this conclusion. If I stay home, I will not catch COVID-19. Let's assume that premise is true. I did not stay home. That premise is true. This says that we cannot draw this conclusion logically. So even if these premises are true, that does not mean that I will catch COVID-19. I could, but it's not a guarantee that I will. So that's how you can determine if an argument is valid or not. Translate the argument symbolically, the premises and the conclusion. Set up the implication by taking the conjunction of the premises pointing to the conclusion. Set up and complete the truth table for the implication. If the implication is a tautology, meaning the last column is all true, then the argument is valid. If the implication is not a tautology, even if there's just one false, then the argument is invalid.